Hello there and welcome. I'm so glad you've joined me tonight. You have found your way to a quiet place, a place of rest. Tonight's journey takes us into the quiet company of moons. You don't need to do anything at all. Just settle in. Find a comfortable position, letting your body feel heavy and supported. Let your breathing slow, a gentle, easy rhythm. Let the quiet rhythm of these moons carry you. These wandering companions drift around planets, large and small, shaping tides, stirring atmospheres, and hiding secrets deep beneath their surfaces. Some are scarred and ancient, silent witnesses to billions of years of cosmic history. Others are restless, alive with volcanoes, geysers, and shifting ice. Our journey is a gentle one. There is nothing to learn, nothing to remember. Simply allow my voice to be a soft guide, a quiet whisper in the background as you drift. If you're ready, let's begin. Let the universe cradle you as you prepare for a deep and restful sleep. Let us start our journey with the world we know best, our own moon. It hangs in our sky, a familiar, steady presence. But even this constant companion is quietly changing with time. Every year, our moon drifts about an inch and a half farther away from the Earth. This slow escape happens because Earth's rotation stirs the oceans into tides, and those tides transfer energy to the moon, nudging it gently outward. This means that long, long ago, in a time before memory, the moon hung closer in the sky. It would have appeared much larger, much brighter, its silvery light bathing the young Earth, its pull on our world more powerful. And as the moon drifts away, it has a subtle effect on our own planet. In the distant future, Earth's days will grow longer as the planet's spin slowly slows down. This process is incredibly gradual, a slow dance between world and moon playing out over eons. The sky we see tonight is not the same sky our distant ancestors saw, and it will not be the same one our descendants inherit. The leading theory of our moon's origin is one of fire and chaos. About 4.5 billion years ago, a body the size of Mars, nicknamed Theia, collided with the young Earth. The immense impact blasted molten rock and debris into orbit, which gradually came together, coalescing into the moon we see today. This is why Earth and the moon share such strikingly similar chemistry, as if they were born from the same material. What looks so calm and timeless in our sky is the beautiful result of a catastrophic planetary collision, a scar of Earth's early history turned into its most faithful companion. The moon you see now, so silent and still, was not always this way. Billions of years ago, the moon was not the airless world we know. Volcanoes once erupted across its surface, releasing great plumes of gas. So much gas was released that the moon briefly held a thin, but very real, atmosphere of its own. This atmosphere was thick enough to linger for tens of millions of years, a fleeting breath in the moon's long life, but it was too fragile to last forever. The gases gradually escaped into space, leaving the moon bare and exposed once more. Scientists believe this ancient atmosphere might have helped water molecules find their way into deep, shadowed craters, where they remain frozen even now, hidden from the sun. When the Apollo astronauts first walked on the moon, they discovered the fine gray dust that covers its surface clung to everything, and when they returned to their lunar module, it gave off a distinct smell, like spent gunpowder. This lunar dust, or regolith, is made of tiny, jagged shards of rock and glass, ground down by billions of years of meteorite impacts. With no wind or water to smooth them, The grains remain incredibly sharp and abrasive, and in this dust there is a hidden treasure. Scattered across the lunar soil are countless tiny glass beads formed in the fire of those ancient volcanic eruptions. Scientists recently discovered that these microscopic beads contain water locked deep within them. Though the moon looks so dry and barren, it may store vast amounts of hidden moisture in its dust, a quiet resource waiting in the silence. Though the moon seems eternally silent, it occasionally trembles. Seismometers left behind by the Apollo astronauts revealed the existence of moonquakes. Some are caused by the tidal stresses from Earth's powerful gravity, a constant, gentle pull on the moon's body. Others happen when the cold lunar crust suddenly warms with sunlight, causing it to crack and shift under the temperature change. And then there are deeper, stranger quakes that come from within the moon itself, their origins still not fully understood. These moonquakes can last much longer than earthquakes because the moon's crust is so dry and rigid, allowing the vibrations to echo for hours. After a meteorite impact or a deep quake, the moon rings like a bell, its whole body humming with hidden energy. We only ever see one face of the moon from Earth, the near side. This is because it is tidally locked, rotating once on its axis in exactly the same time it takes to orbit our planet. For most of human history, the far side remained a complete mystery, unseen until spacecraft finally revealed it in the 20th century. And it is strikingly different from the side we know. The near side is marked by broad, dark plains called Maria, which are ancient seas of frozen lava. But the far side is covered in rugged, cratered highlands. It's like discovering a second moon, one that was hidden just out of view all along. Let us now drift farther out into the deep blackness of space, moving toward the giant of our solar system, Jupiter. Circling this immense gas giant are dozens of moons, a miniature solar system in itself. In 1610, the astronomer Galileo turned his telescope to Jupiter and saw four tiny points of light moving beside it. Night after night, they shifted, and he realized they were moons in orbit. This discovery was revolutionary. It proved that not everything in the heavens revolved around the Earth. Let's journey now to the innermost of these four great moons, a world of fire named Io. Io is the most volcanically active world in the entire solar system. Its surface is scarred with hundreds of active volcanoes, some shooting molten fountains for miles into the sky. These incredible eruptions are fueled by the immense tidal forces of Jupiter and its neighboring moons, which constantly stretch and squeeze Io, generating immense heat deep inside. The entire crust of Io is restless, constantly being reshaped by flowing lava. Its lava flows can stretch for hundreds of miles, great rivers of molten rock glowing red hot. The air is thin, and the radiation from Jupiter is deadly. But from afar, Io dazzles, glowing with the fiery energy of a world forever in upheaval, a living furnace in orbit around a giant. Now we drift gently away from the fire of Io to a neighboring world that is its complete opposite, Europa, covered in a shell of brilliant, cracked ice. Europa is one of the smoothest objects in the solar system, but beneath this icy crust lies something truly extraordinary, a global ocean of liquid salt water. Evidence suggests that this hidden ocean could contain more than twice as much water as all of Earth's oceans combined. This vast ocean remains liquid, not because of sunlight, but because of the same tidal forces that fuel Io's volcanoes. Jupiter's immense gravity constantly stretches and flexes Europa, generating enough internal heat to keep the water from freezing solid. The surface is a vast sheet of fractured ice, crisscrossed with long lines and reddish streaks. This is a young and active surface. The ice is constantly shifting, breaking, and refreezing, erasing older craters and scars. Some scientists imagine hydrothermal vents on its deep ocean floor, places where warmth and minerals could mix, perhaps creating the very chemistry needed for life. Though it looks barren and cold on the surface, Europa may be one of the most promising places in our solar system to find life beyond Earth. A silent, icy world hiding a vibrant, teeming possibility in its depths. Our journey continues onward to the two largest of Jupiter's companions. First, we approach Ganymede, the largest moon in the entire solar system. Ganymede is so large, it is bigger than the planet Mercury. If it orbited the Sun on its own, we would almost certainly call it a planet. What makes Ganymede truly unique is that it has a magnetic field of its own, something no other moon can claim. This suggests a molten metallic core hidden deep inside, churning away like a miniature planet. This magnetic field is strong enough to create auroras, shimmering curtains of light that dance above Ganymede's poles. Some scientists believe that beneath its icy surface, Ganymede may have multiple oceans stacked in layers, like a cosmic sandwich of ice and liquid water. Next, we drift to Callisto, Jupiter's second largest moon. At first glance, Callisto seems frozen in time, geologically still. Its surface is scarred with more craters than almost any other world in the solar system. It is a frozen record of the solar system's violent youth. Some of its largest impact scars may be nearly 4 billion years old, preserved because Callisto lacks the geological activity that erases them. But even here, there are hints of a secret. Measurements suggest that Callisto too may hide a salty ocean deep beneath its ancient, icy shell, a quiet, preserved sea, perhaps as old as the solar system itself. Let us leave the family of Jupiter behind now and continue our gentle drift outward toward the soft, golden light of Saturn, the ringed planet. Saturn is home to a vast and complex family of moons, more than any other planet. They range from giants that rival planets to tiny, irregular bodies that look like space rocks. Saturn's dazzling rings are not just passive structures of ice and dust. They are shaped and sculpted by its tiny moons. These small bodies are called shepherd moons, and their gravity tugs at the ring particles, creating sharp edges, gaps, and beautiful, rippling waves. A tiny moon, named Pan, for example, orbits within the rings, helping to carve a gap in Saturn's rings. Without these shepherd moons, the rings would be a blurry, indistinct haze. Their interplay is a cosmic artwork, a dance of gravity sculpting beauty from countless icy fragments. Some of Saturn's smaller moons may have actually formed from the rings themselves. Scientists believe that icy particles within the rings clumped together under their own gravity, slowly growing into moonlets that eventually became the small moons we see today, orbiting at the ring's edge. The rings are like a glittering, fragile nursery where new companions can be born. Now we drift towards Saturn's largest moon, a world shrouded in mystery. Titan. Titan is the only place beyond Earth known to have stable bodies of liquid on its surface. But this is a world of alien chemistry. Instead of water, Titan's rivers, lakes, and vast seas are filled with liquid methane and ethane. Titan is also unique for having a thick atmosphere, even denser than Earth's. Its sky is a thick orange haze filled with nitrogen and complex organic molecules. This thick air allows for weather. Clouds drift above, and rain falls, but it is a rain of liquid methane that shapes the landscapes below. Imagine standing there, under that hazy orange sky, the air pressing down heavily. The horizon is lined with shimmering hydrocarbon seas. In the frigid temperatures, mountains of solid water ice, as hard as rock, rise taller than Earth's Rocky Mountains. This strange cycle of rain and rivers might even hint at organic chemistry similar to what first sparked life here on Earth. Titan is a frozen snapshot of what our own primordial planet may have once been like, a world both eerily familiar and profoundly alien. Let us now visit one of the most fascinating worlds in the entire solar system. Tiny Enceladus, this small moon of Saturn, gleams like a freshly polished pearl against the blackness of space. Its surface is covered in fresh, clean ice, making it one of the most reflective objects known. It shines so brightly because its surface is continually renewed. Beneath its icy crust lies a salty, liquid ocean, and near its south pole, great cracks in the surface, known as tiger stripes, are constantly erupting. From these fissures, spectacular geysers spray water vapor, ice crystals, and organic molecules hundreds of miles into space. These dazzling plumes are so powerful that they help to create and feed Saturn's vast E-ring. Every particle in that delicate ring may have once been part of Enceladus's hidden ocean. The material in these geysers suggests conditions that could support microbial life. The Cassini spacecraft even flew directly through these plumes, tasting their chemistry. Enceladus is a tiny moon that constantly announces the presence of its hidden, life-giving ocean with spectacular, glittering sprays. Saturn's family of moons is full of strange and wonderful characters. Let us visit a few of these quirky companions. We approach Mimas, a small, battered moon that became famous for its uncanny resemblance to the Death Star from Star Wars. A giant crater named Herschel dominates one hemisphere, giving it that same eerie look. The resemblance is pure coincidence, but it has captured the imagination of all who see it. Next, we drift to Iapetus, a moon that looks like a yin-yang symbol painted across the sky. One side of Iapetus gleams as bright as fresh snow, while the other hemisphere is stained as dark as coal. This striking two-toned appearance is thought to be caused by dark dust from another moon, Phoebe, coating one side as Iapetus sweeps through space. Iapetus also has a great equatorial ridge that makes it resemble a walnut. Nearby, we find Pan, one of Saturn's smallest moons, shaped so strangely it hardly looks real. It has a bulging equatorial ridge that makes it resemble a piece of ravioli or a flying saucer. This odd shape comes from the way it sweeps up material from Saturn's rings. And then there is Hyperion, which looks like a giant, tumbling sponge. Its rotation is chaotic. Instead of turning steadily, it tumbles unpredictably through space as if it is forever losing its balance. Among Saturn's many wonders is a pair of moons that perform a delicate celestial dance. Two tiny moons, Janus and Epimetheus, share nearly the same orbit, but instead of colliding, they gracefully swap places every few years as the inner moon, which moves slightly faster, catches up with the outer moon. Their mutual gravity comes into play. They don't crash, but instead exchange energy. The inner moon is nudged outward into a higher, slower orbit, while the other slips inward into a lower, faster orbit. This orbital ballet has repeated endlessly for millions of years, a graceful rhythm choreographed by gravity itself. It is a rare and beautiful arrangement, showing how moons can find perfect stability even in the most precarious of positions. Watching them trade places is like seeing partners in a cosmic dance, forever circling their great planet, never colliding, but always moving in perfect harmony, leaving the gas giants behind. We now drift inward toward the red planet, Mars. Mars has two small, irregular moons, Phobos and Deimos. They are not spherical like our moon, but look more like lumpy, captured asteroids. Phobos, the larger of the two, resembles a bumpy potato. Phobos orbits very close to Mars, so close that it is doomed. With every orbit, it creeps a little closer to the planet. In around 50 million years, Mars's powerful gravity will either tear Phobos apart, shattering it into a new ring around the planet, or pull it down to crash into the Martian surface. The long, strange grooves that streak across its surface may already be signs of this immense stress, the first fractures of its slow destruction. Its companion, Deimos, is smaller and orbits much farther away. From the surface of Mars, Deimos would look like a faint star drifting lazily across the sky. It rises and sets so slowly that it hardly seems to move at all. Its quiet, gentle presence is a stark contrast to the dramatic, doomed race of its sibling Phobos. Our journey now takes us back to the outer solar system, to the icy, tilted realm of the planet Uranus. Unlike most planetary moons, which are named after figures from mythology, the moons of Uranus are named after literary characters, primarily from the works of Shakespeare and Alexander Pope. Titania, Oberon, and Ariel circle this distant world, a library of characters in orbit. Let's visit one of its most fascinating moons, Miranda. Miranda looks like a patchwork of broken pieces that were stitched back together haphazardly. Its surface is a chaotic jumble of cliffs, valleys, and ridges. Scientists believe that Miranda may have been shattered in a massive collision long ago, only to reassemble under its own gravity. This violent past explains its strange, mismatched terrain. And on this small, scarred world, we find the most striking feature of all, Verona Rupes, a cliff estimated to be up to 12 miles high, the tallest known cliff in the solar system. A fall from its edge would take a full 10 minutes to reach the bottom because of the moon's low gravity. Miranda is a cosmic survivor, a quiet testament to cosmic trauma. We now journey to the very edge of the planetary realm, to the deep blue world of Neptune. Its largest moon, Triton, is an oddball. Most moons circle their planets in the same direction that the planet spins, but Triton does the opposite. It orbits backwards, a motion called retrograde. This strange path is a strong clue that Triton did not form around Neptune. Instead, it was likely a wandering dwarf planet from the Kuiper belt, the distant realm of icy bodies that was captured by Neptune's immense gravity long ago. The capture would have been a violent event, disrupting and scattering Neptune's original family of moons. Today, Triton is an icy, geologically active world. Its surface is made of frozen nitrogen, and geysers spout nitrogen gas into its thin atmosphere, leaving dark streaks across the icy plains. Its backward orbit, however, may one day seal its doom. Neptune's gravity is slowly dragging it inward, and eventually it may break apart to form a magnificent new ring around the planet. Let us drift now into the Kuiper Belt itself, to the dwarf planet Pluto. Pluto is not alone. It has 5 moons, the largest of which is Charon. Charon is so large relative to Pluto, about half its size, that the two are sometimes called a double dwarf planet system. Unlike the relationship between Earth and our moon, where the smaller body clearly circles the larger one, Pluto and Charon both orbit around a shared point in space that lies outside of Pluto itself. It is less like a planet with a moon and more like two companions forever turning together in the dark, locked in an equal dance. Charon's surface is scarred by an enormous system of canyons, a great chasm that stretches over 1,000 miles across its surface and plunges nearly 4 times deeper than Earth's Grand Canyon. This colossal feature, likely formed as Charon's icy interior, expanded long ago, cracking the crust wide open. This unusual partnership, a tiny double world at the edge of our solar system, blurs the line between planet and moon. As you continue to drift deeper into relaxation, let's reflect on the silent, gravitational rhythms that govern these worlds. Many moons, including our own, are tidally locked, always showing the same face to their planet. This happens as gravity gradually slows a moon's rotation until it matches its orbit, creating a perfect, stable rhythm that feels almost like a dance. Sometimes, moons are locked in an even more complex pattern called an orbital resonance. 3 of Jupiter's largest moons, Io, Europa, and Ganymede, orbit in a perfect 1-2-4 rhythm. For every one orbit that Ganymede makes, Europa circles exactly twice, and Io circles exactly 4 times. This steady, repeating pattern helps maintain the tidal heating that fuels Io's volcanoes and keeps Europa's ocean liquid. It is a cosmic metronome, ticking with perfect precision for billions of years. And orbits are not always stable forever, as we have seen. Some moons, like Mars's Phobos, are slowly spiraling toward their planets, while our own moon is slowly drifting away. These cosmic cycles show how dynamic and fragile orbits really are, even though they seem so timeless to us. They are a reminder that the solar system is full of chance encounters and dramatic captures that reshaped worlds into the configurations we see today. As we have journeyed, we have seen that moons are not just quiet, cold rocks. They can be dynamic worlds of ice and fire, shaped by powerful forces from within. The secret to this energy, for many, is a gentle process called tidal heating. As a moon is stretched and squeezed by its planet's gravity, friction deep inside generates heat. This warmth can keep entire oceans liquid, even under miles of thick ice. This hidden energy reveals itself in spectacular ways. On Io, it fuels hundreds of active volcanoes, creating a world of fire. On Enceladus, it powers geysers that spray shimmering fountains of water and ice hundreds of miles into space. And on distant Triton, it vents nitrogen gas into a thin, cold atmosphere. This internal energy also leaves behind colossal scars. On the fractured moon, Miranda, it created Verona Rupes, the tallest cliff in the solar system, a monument to a time it was shattered and reassembled. On Pluto's moon, Charon, it cracked the crust wide open, carving a canyon 4 times deeper than the Grand Canyon. These features remind us that moons can be as complex and active as planets themselves, each with a unique story of geology and magnetism written across its surface. As our journey nears its end, let us ponder one of the most profound questions. Could life exist on these moons? When we search for habitable worlds, we often picture planets like Earth, but moons may be just as promising. Worlds like Europa and Enceladus, with their vast subsurface oceans warmed by tidal heating, may harbor hydrothermal vents on their seafloors. On Earth, such vents teem with life that thrives in total darkness, fueled by chemistry alone. If similar vents exist in those hidden oceans, they could provide the energy for alien ecosystems to emerge. Titan, with its thick atmosphere and lakes of liquid methane, hosts a rich environment of prebiotic chemistry. The complex organic molecules raining from its sky could be the very building blocks from which life arises. These moons remind us that the ingredients for life, liquid water, energy, and organic compounds, are scattered widely in the cosmos, perhaps waiting in the dark beneath alien ice or in the hazy skies of a distant moon. The moons are not just distant scientific objects, they are deeply connected to us. Our own moon does more than light the night sky. It acts as a cosmic anchor and guardian. Its steady gravitational pull stabilizes our planet's tilt, keeping our seasons regular and our climate relatively stable over billions of years. Without the moon, Earth's axis might wobble chaotically, making life as we know it impossible. It also acts as a shield, its scarred surface, a record of countless impacts it has intercepted that might have otherwise struck Earth. The discovery of Jupiter's moons by Galileo reshaped our entire understanding of the universe, proving that Earth was not the center of all things and opening the way to our modern view of the cosmos. And as humanity looks to the stars, moons may become our stepping stones into the future. Our own moon, with its frozen water, could host future bases, and the moons of Mars could serve as staging grounds for missions to the red planet. And so, our quiet journey among the moons comes to a close. We have drifted from the familiar face of our own companion to the fiery volcanoes of Io and the hidden oceans of Europa. We have seen moons shaped like potatoes, moons larger than planets, and moons that dance in perfect rhythm. Each one is a reminder that the universe is rich with quiet, beautiful companions, orbiting in an endless, gentle rhythm. As you now drift deeper and deeper towards sleep, let these thoughts circle gently like moons around a planet. There is no need to hold on to any details now, only the feeling of vastness, of quiet worlds in orbit, of time stretching across billions of years. Let the day settle completely behind you. Let your breathing fall into its own steady, calm, and unhurried orbit. Imagine yourself drifting weightlessly now, like a moon bathed in pale starlight, carried endlessly and safely through the quiet dark. The night sky is full of stories, and the moons are among its most beautiful, peaceful whispers. Sleep well, dream deeply, and may your night be as peaceful as the quietest of moons. Good night.